Good morning, folks. Welcome along to this morning's session on SQL Server 2017. My name is Peter Ward. I'm the Managing Director for WARDY IT Solutions. I'm a SQL Server MVP in the data platform space, and I also sit on the Partner Advisory Council for SQL Server as well. What I want to do today is I want to take you on a journey of discovery. What we're going to do is we're going to unpack some of the new features that are available inside of SQL 2017. When we think about a release of SQL Server, there's always a number of features inside of the product. What we're going to walk through is just a handful of those, and those that I think are most significant and will affect most people, whether you're a DBA or whether you sit in the data analytics space, or maybe you're a business user that's starting to leverage SQL Server for a number of the insights you can start to provide. Now, when I think about SQL Server, I've been working with it since SQL Server 6.5, and back then I could understand the product and I knew the features inside and out. Really, back then it was nothing more than a data platform. But as SQL Server has evolved over the last 25 years that it's been available, what we're starting to see is that the product is becoming very, very broad. We've got features like master data services, we've got then also data quality services, reporting services, analysis services. All of these individual components make up a very broad data platform. But the data platform is now being significantly extended is because the data platform is now reaching into the Microsoft Azure platform as well, introducing things such as platform as a service where we have features like the SQL Data Warehouse. We also then have features such as SQL Data Factory, and these extend and create a well-rounded product, and we'll be covering some of those as we walk through the presentation today. Now, when we think about the need for a new version of SQL Server, if you cast your mind back, SQL Server 2016 was only released about a year ago. But when we think about what's happening in the world today, data has never been at a faster cadence. We're creating larger volumes of data, we're needing to store different varieties of data, and just the sheer volume is just exponentially growing year on year. As a result, we need to have a database platform that maintains that cadence. Now, one of the great things about releases of SQL Server these days is that many of the features are released into the cloud before they're released into the box product. So what that means is these features have been tested at hyperscale. Often thousands or even hundreds of thousands of customers have already battle-hardened those features before they become available inside of the box product. Now, if we think about what's happening, we have this changing data landscape. Now, when we talk about data, we've been talking about a data explosion for many, many years. Now, that data explosion was traditionally driven by two factors. One was around the need to keep data for longer periods of time from a compliance perspective or an audit perspective, but we also then had the need to keep larger amounts of data in order to be able to satisfy that pent-up demand for data analytics solutions as well. Because if we didn't keep data for large periods of time, often we're not able to identify the patterns and trends inside of that data. Now, what's happening with this massive data growth is it's no longer just those two traditional factors of audit and compliance as well as data analytics that's driving those. What we're having is new sources of data that are generating data in larger volumes than we've ever seen before. Now, when we look at data today, we look that in 2017, we'll probably generate around about 20 zettabytes of data. It's predicted that by 2020 that will grow to 50 zettabytes worth of data. So to give you a context of what a zettabyte is, it's basically the equivalent of every single person on the planet having 2 iPads full of data. Now, this data that's being generated is not just funny cat videos on YouTube. It's a number of different sources, whether that's sensor data from a Fitbit device that you might be wearing, through to GPS tracking that's on your mobile phone, all the way through to other sensors that it may have inside of your own house, such as your alarm system or even your personal video recorder. All of these devices are creating data. But what organisations are now starting to do is look at this unstructured data. There's value inside of it, and we can start to gain insights. And there's new business models that are being then driven as a result of this. So when we think about data, we traditionally think about data as ones and zeros or bits and bytes that are stored inside of a database. However, there's data that's available in many different sources, including sound files and images. And what SQL Server 2017 brings to the table is it's the first database platform on the planet that has AI built in out of the box. So what this allows us to do is drive digital transformation with modern analytics. Now I want to tell you a little bit of a story that really outlines this. So my wife and I were recently driving along a country road to go to a pub on a Sunday to go and have my favourite meal, which is a chicken parmigiana. And we were driving along in the middle of nowhere and a police car came past us the other way. All of a sudden that police car turned around and it lit the Christmas tree up and pulled my wife over who was driving. So my wife always drives within the speed limit and obeys all of the rules. What we found out that had happened when we pulled over is that the registration on our car had expired, so we were driving an unregistered vehicle. But what the police car had built into it is what's called a LiDAR. That LiDAR allowed it to take a picture of our registration plate. That registration plate was then, the text image was read out of that, so they're able to read the registration of that. It was then able to then pass that back to a line of business system in order to be able to go and do the lookup to identify that the car was unregistered, and it was able to do that all within the 15 seconds it took for the car to pass us before it turned us round. And that's really a great example of how we're using different data sources to be able to start to provide business insight inside of organisations. Now, if we look at what's happening across the world today, the time for disruption is dramatically shrinking with large organisations. So if we look at the S&P 500 index, which is a measure of some of the largest organisations on the planet today, typically we found that those organisations had a lifespan of 67 years that they were listed inside of that. What we're now starting to find is that in 2020 is that the S&P 500 will be made up of many organisations that we haven't even heard today. And if we look at some of the largest market cap organisations in the world today, so organisations such as Facebook, Apple, Google, Microsoft, these are organisations that are using data to go and drive business disruption. So what that means for us though is as organisations we need to then think about data differently, especially because the speed of data is so quick today. There's organisations that are disrupting traditional business models. We look at organisations like Airbnb, the largest hotel provider in the world, yet it has no hotels. We have Uber, which is the largest taxi company in the world, but it has no physical assets in regards to vehicles there. So SQL Server 2017 provides a platform that enables these new world businesses to be so successful. Now, if we look at just a couple of examples of how businesses are being able to drive disruption, we look at products like DocuSign that's dramatically transformed the way that we then process traditional documents. Having recently just purchased a new house, I can attest to the painful process that is having to then sign a document and get that back. So when I buy a house, the solicitor goes and sends me a document. I need to sign that, scan that in, send that directly back to my solicitor, who then goes and sends it to the vendor solicitor, and the vendor then goes and prints the documents out, sends it, and then retrieves that directly as well. What DocuSign has is dramatically then streamlined that whole process, but also provides insight about when somebody's viewed a document or how quickly that can be turned around. We look at organisations like Jet that's transformed the retail landscape. But when we think about digital transformation, many organisations see digital transformation as nothing more than a buzzword. But when I think about what digital transformation is, it's using data to provide business insight and streamline business processes. Now, I cast my mind back to a story that my dad often tells me. So my dad was one of the traditional people that worked in the same organisation for 40 years of his life. Throughout that time, he saw massive change going on. He worked as a spare parts controller and then moved to be a spare parts manager and then ran the new car division of Metro Ford. But throughout that time, he tells me the story that when he first started work at 18 years old, he had this business process that was made up of an in tray and an out tray. So in the morning he would come in and his intro would be full of documents. He would then work through each of those documents, whether it was ordering a part or then looking to see when somebody's car needed to be serviced or whether it was under warranty. And then when he was finished with that individual document, he would then go and put it in his out tray. Then someone would come along in a trolley and move that out tray then down to somebody's in tray. Several years later, though, what he found is that rather than sitting an in tray and an out tray on his desk, he had a computer. All of a sudden, there were a line of business systems such as CRM systems that had customer information, an ERP system that had stock on hand information and other parts that could be ordered there. Now, what we're now seeing is that rather than having line of business systems, that we're automating that process end to end. And a great example of that is an experience I had with Uber recently. I was in San Francisco and I was catching an Uber ride directly from my hotel on Union Square out to the airport. Now, for many of you that are familiar with Union Square, you'll know that the hotels there have two entrances. There's one on the main square and there's one that runs off the avenues parallel to the square. Now, I had a lot of luggage because I was bringing back a number of fun things that I'd organised in the US, and as a result, I wanted to be picked up directly inside of the avenue there. So I ordered my Uber ride, and my Uber ride I could see on the map was at the wrong entrance. The driver called me, and then I told him where I was, and at that point then, the ride was cancelled. So I then had a look at my bill and received the $5 cancellation fee there, and I wanted to dispute that because I knew where the Uber driver was and I knew where he should have been. So if you think about a traditional business process, I would normally call up a call center, or I'd wait in a queue and someone would tell me that my call is very important to them. Once there's finished that, someone would take my details and then the call would be investigated, and then they would then look at the dispute. And that would take several days and a number of different people to look at that. What Uber was able to do is automate that whole process. So they could identify my location from my geolocation on my phone. They could also identify the GPS coordinates of the driver and identify that the ride shouldn't have been cancelled, and I have that refund recorded back to me within 15 minutes. So that's an example of what digital transformation is and how we need a modern data platform to support that. Now, what we're looking today is that a business leader is trying to then enable this business agility and adopt this business change. They're looking to then experiment with new business models, but also looking for deeper customer engagement and how to differentiate with our customers. The challenge, though, for business leaders is that harnessing technology is not always easy. Now, if we think about managing a database inside of our own organisations, whether that's a data platform delivering business insight or whether that's a data platform that's providing line of business support, it's difficult for us to achieve. We have challenges around security. We also have challenges around many applications that aren't supported on modern versions of SQL and legacy ways of doing things. But we also find that even doing things like predictive analytics is very difficult. Now, if you cast your mind back, I'm sure many of you have been involved in a data warehouse project that hasn't gone successfully. And that's because IT is hard. It's very difficult often to then go and implement these technologies and processes when we're using older versions of SQL Server. By moving to a modern platform, it enables us to then achieve this business agility with ease. Now, when we look across the Microsoft landscape today, what we have is what's called the modern data estate. Now, this data estate is made up of a number of different layers, and you'll see those on the screen there. The first is our operational data, or our traditional line of business data that sits inside of our database. We have our data warehousing component as well that sits over the top of that, so that's where we then go and take our operational data and start to provide business insight. But we also have the need to then think about big data processing as well, and a platform that not only supports operational data and data warehousing data, but also the ability to support the large volumes of data, the variety of data, but also the velocity of data that we need to work with today. And that's where we can then start to provide business insight. So whether that's through business intelligence solution or advanced analytics and artificial intelligence there. And when we walk through the presentation, we're going to focus on what SQL Server 2017 brings to each of these different layers inside of the data platform landscape we have today. So when we talk about SQL Server 2017, one of the key things is to understand the ability for us to have a consistent experience whether we're deploying on-prem, in the cloud, or in a hybrid scenario. So what that means today is that we can then go and take our SQL Server 2017 environment, we can then go and deploy that directly inside of an infrastructure as a service environment inside of the cloud. We can also then move to a full platform as a service as well, and means that we've got consistency and experience, whether we deploy on-prem with a box product, whether we deploy inside of the cloud using IaaS, or whether we deploy through to a platform as a service with the SQL Server Azure service as well. So what that means is we can easily then lift and shift workloads and migrate them around as the workload changes or the demands on that particular workload change as well. But the key there is it's a consistent experience across each of those. So what we're going to do is walk through each of the different parts of the data platform landscape and identify what key benefits SQL Server 2017 starts to provide. Now, when we think about operational data today, I always think about performance because that's the number one factor that everybody wants out of a database, is to make sure that it goes fast. Now, when I think about SQL Server, we really have a true mission-critical database there. And I talk about mission-critical when I talk about fast, because there's no point in having a database that's fast if the database is unreliable. And the analogy I often use to describe SQL Server is, if I think about the fastest cars on the planet, the fastest cars on the planet are Formula One cars. But the problem with a Formula One car is it's not very reliable. It only typically does 50 to 60 laps, and then after that, they're not particularly reliable. But also, if I were to store one of those cars directly on the line, I don't have the ability to start them up again. So although they're super fast, they're not particularly reliable. Where if I look at then a car that's raced inside of Le Mans, so Le Mans being the classic 24-hour car race, that's a car that's able to then go around the track and do speeds of in excess of 360 kilometers an hour, but do that for 24 hours straight. Because one of the key differentiators with Le Mans is that each of those cars need to pit every hour in that 24-hour race, and they need to turn the engine off and turn the engine back on again. Because when you turn the engine off and turn the engine back on again, that's where the most amount of workload is on that engine there. So it's a test of reliability. So what you'll see from a Microsoft SQL Server standpoint is it's been an industry leader for 4 years in a row in the Transaction Processing Council benchmark there, in the TPC-E score there. What you'll also see is it's also not only is from an operational data perspective, it also has the #1 performance in the TPC benchmark for TPC-H. And SQL Server 2017 is a platform that's designed to scale to petabytes. Now, when we think about data volumes today, having a database that's a petabyte in size is no longer uncommon. It's actually becoming the norm for many organizations to have databases that are at that scale. But one of the key processes is we talk about this big data processing as well. Now, I don't want to think about what platform I use when I go and store large amounts of data. As a DBA or someone that works in the BI space, one of the tools that I'm familiar with is using T-SQL. So what I can do with SQL Server 2017 is I can go and use Polybase to be able to query data no matter where it lives. So I can query data whether that lives directly inside of my SQL Server environment, but I can also query that directly inside of Hadoop with the tools that I'm very, very familiar with. So if we think about a database platform and one of the key aspects of that, we spoke about performance, but the other one is also around security as well. And the key thing to be aware of from a Microsoft perspective is that SQL Server has had the least amount of vulnerabilities of any database platform in the world there. And if we look at the statistics there, SQL Server is the most widely deployed database in the world today. Effectively, almost 1 in 2 databases deployed a SQL Server. So to be able to have a database that's that secure and deployed at that scale is certainly a testament to the rigor and the governance around the security of the SQL Server product. What we can also then do now with SQL 2017 is introduce advanced analytics to change many different business scenarios. So all of a sudden, the ability for me to then undertake 1 million predictions per second opens up new business cases and scenarios that I would not have access to previously. But the key thing really that we have with SQL Server 2017 is the flexibility of the platform. That allows us to use whatever language we want, whether that's Node.js or .NET or Java, but also the ability for us to deploy on any platform as well. So SQL Server 2017 opens up a deployment methodology that allows us to deploy in a container, it allows us to deploy to Windows, and it also allows us to deploy directly to Linux for the first time as well. And I think this is one of the biggest game changers changes in SQL Server 2017 is that flexibility of deployment model. So depending on what my use case is, I can choose where I want to be able to deploy and have a consistent experience across each of those platforms. So when we think about any release of any SQL Server, there's really these three core tenets of the product, and we've seen that for the last few releases. So if we look at the key core tenets of SQL Server 2017, one is an intelligent platform. So that intelligent platform is the ability for us to have AI built directly inside of the product. So not only do we have R available natively inside of the database environment now, we also introduce Python as well. So it doesn't matter what data science language I want to be able to use to get data insights, I have a flexibility in the language of choice. So I can also go and build models and predictive analytics directly out of the box inside of SQL Server and have all of my data accessed here, be able to then go and leverage them. One of the key things is about a trusted database environment, so the most secure database on the planet, but also the most performing database on the planet as well. And we'll talk about this flexibility a little bit more when we start to talk about the ability to deploy on any language with any platform, when we start to unpack and discover the ability for SQL Server 2017 to be deployed on Linux. So when we think about SQL Server 2017, there's a number of features that enable massive performance improvements there. Now, one of the key things there is the ability for us to improve transactional performance with our in-memory OLTP technology. So that allows us to then go and take individual objects and pin them directly into memory. Now, one of the great features about SQL Server 2017 across a number of the competitive products in the landscape is I have the flexibility to pick and choose what I want to put in memory. It's not an all or nothing scenario, but it also means that I can use all of the same TSQL and all the same features. I don't need to use different syntax across that. So it provides advanced capabilities there to have massive performance improvements when I use in-memory OLTP. I've also got the ability to go and use column store compression as well. Now, compression is not something new that's inside of the database platform. It's been there for many years. We've had row-level compression and page-level compression that first got introduced in the 2008 genesis of SQL Server. But now what we've got is column store compression, the ability to then go and compress an individual column that provides dramatic performance improvement and speeds analytics. So if I have a BI solution or a data warehousing solution, a column store index is a great idea to then explore how that might be able to give me advantages there. The other feature that we introduced in SQL 2017 is also what's called hybrid analytics as well, which is also known as real-time operational analytics. So often I'd have a scenario where if I was trying to do large workloads of reporting directly on side of my line of business systems, it would often have an impact on those line of business systems there. So the OLTP systems are often made up of short, sharp, autonomous transactions, such as updating a stock on hand, changing somebody's surname, or maybe changing their address. But when we think about an OLAP query, they're a very different type of query. So asking, show me all people that have placed an order for a red jumper in a particular suburb between a particular age demographic is a very, very different type of query. So what we would often do in the past is we would try and move that OLAP workload to a reporting environment. We might use something like replication to move that data across, or we might be using another technology in order to make that available through SSIS. But one of the challenges with those is we have then that latency of data movement as well. It's no longer good enough for us to have data that's an hour old or sometimes even 15 minutes old. So by using real-time operational analytics, it allows us to then have access to that data directly in real time. Now, the two next features we're going to talk about are the adaptive query processing and automatic plan correction. Now, when we think about traditionally, Microsoft then created a fantastic product with SQL Server. They would ship it on a DVD or put it on an ISO, and effectively it was then up to the DBAs to then manage that environment at that point in time. However, now running at hyperscale inside of the cloud, all of a sudden Microsoft is not only creating the product, but they're also then having to provide operational support and maintain the use of that product 24/7. So as a result, there's a need for them to gain greater insight when running at hyperscale than was ever required before. So what we've now seen inside of the cloud products with SQL Server is we have adaptive query processing. So that allows us to then identify a poor performing query and dynamically then go and tune that query. What it then also does is alerts us. So inside of the dynamic management objects, we can then go and see when that happened, and we can then go and take that query and put that on our product backlog to then look at a later point in time. Likewise, we also have automatic plan correction as well, and that allows us to identify poor performing plans and then dynamically adapt and change those plans to ensure that we get the maximum amount of performance out of our database platform, no matter what workloads we're throwing directly at that. But the key thing for that is that we've provided all of those insights so we're aware of when the query processing and when the plan correction kicks in. The next thing we're going to talk about is the mission critical capability. So this is the ability for us to deploy SQL Server always on directly inside of multi-platform environments. So if we think about today, traditionally when we go and deploy SQL Server, we would only deploy SQL Server on Windows. But as a result, we've always got that risk at the OS level. If we then start to go and do an operating system level patch, that if we do that on one node, potentially we're then going to impact the entire topology there. What we now have the ability to do is decouple that risk by potentially running one of our nodes directly on Windows and one of our nodes directly on Linux. And that's a fully supported architecture that provides redundancy not only at the database level, but also directly at the operating system as well. What we could also do inside of SQL Server 2017 is we can then undertake load balancing as well. So potentially what we might want to do is that our readable secondaries or our secondaries might be on a Linux operating system rather than on a Windows operating system. So it provides a number of different use cases that we can then start to leverage to provide even greater levels of availability inside of our mission critical environments. When we talk about data, data lives in a number of different forms. And one of the forms that's often needed today in a modern environment is the ability for us to use graph databases or being able to then use graph data. So the ability for us to analyze different relationships inside of an environment. So those relationships might be in regards to an organizational hierarchy structure, such as an org chart, or it might be around the number of connections. So we now have full support of a graph database, but also the ability for us to then go and query nodes and edges directly inside of T-SQL as well. We've briefly spoken about the ability for us to go and use Polybase, so that allows us to then query data that's inside of Hadoop directly from inside of our SQL Server platform there, which allows us to then combine data that might be sitting inside of our data lake directly with data that's sitting inside of our operational systems, but also inside of our analytical systems as well. Now, one of the key things for any piece of data is the ability for us to democratize that and make that available to everybody inside of the organization. And one of the things we have available to us is the improvements that have been made inside of reporting services. So with reporting services in SQL Server 2017, it's now fully device agnostic, which means that the solution is delivered via HTML5, meaning that whether I'm using an iOS device or whether I'm using a Windows device or whether I'm even using a Chrome device, I'll have a consistent experience with my reporting services deployment there. What reporting services also does with some of the newer releases and also with SQL Server 2017 is enables me to have a consistent experience with deploying not only reporting services but also deploying Power BI reports directly inside of one central portal there. So Power BI brings the power of data to everybody in the organization. It allows us to take very complex data and roll that up into bite-sized chunks of information that we can then provide in a visual format. We can then actually undertake data discovery directly from that environment, allowing us to then drill in and gain insight into that information. Now, I often talk about Power BI as a great way to enable cornflakes analytics. So cornflakes analytics being that the moment I wake up in the morning, I'm sitting there having my breakfast, I have all of the key business information that I require directly in the palm of my hands there. So what that means is it opens up data for everybody in the organization information to be able to make timely decisions about that, and encourages collaboration and people to then gain greater insight with their data. Now, one of the key things when we're talking about data is that data lives in a number of different formats today. When we think about the traditional SSIS process, where we would have an ETL, where we would extract, transform and load data from a number of different heterogeneous sources, much of our methodology around data movement today has moved more towards a data vault methodology of an ELT, so an extract, load and then transfer, rather than doing that in pipeline. But we also have the scenario where we have large data sets that are outside of our organisation, where it doesn't make sense for us to try and extract and transform all of the data. So for example, we might be using Facebook to gain customer insights and see what are our customers saying about us on Facebook, or how are they transacting directly on our Facebook store. Now, it wouldn't make sense for us to then go and extract the entire Facebook database and bring that directly inside of our own systems. So what we now have is the ability to use modern connectors to connect directly to these sources. So directly inside of our SSIS processes, we can then go and use these other systems. So whether they're software as a service products such as MailChimp, or whether they're other database platforms such as Azure Blobs, or even AWS Redshift as well that we can tap into. So what that allows us to then do is inside of our pipeline then undertake additional customer insights. So we can then go and use some of the advanced analytics capabilities such as sentiment analysis. So when somebody's saying something about my business, or whether we're receiving a call into a call center, was that positive or negative? We've got the ability to identify customer churn, so to be able to look at what are our risk customers, what is the total life value of a customer directly inside of our database, and also be able to then do revenue predictions as well. So being able to identify what we believe based on previous buying patterns will be the revenue from an individual customer today. So really what we're now saying is that our data, no matter where it lives, we can easily then go and have access to that to provide greater insights, and then visualize that in whatever format I want. So whether that's in Excel, reporting services, or inside of Power BI. Now, one of the changes that we're seeing inside of the data landscape today is really around machine learning and advanced analytics. So this is enabling new scenarios that were never possible previously. So in this particular scenario, we're demonstrating how some of the database analytics such as R and Python can be used directly inside of the data platform. Now, what it might be, for example, is in the scenario here where I'm an insurance company. Now, that insurance company often has different interactions with its customers, whether that's via a web inquiry, whether that's by a chatbot, or whether that's by a traditional call center. Now, in this scenario here, what we have is someone that's taking out a loan. So when that person takes out a loan, there's a number of different attributes that are understood about the person. So their age, their credit score, other demographic information in there. So all of a sudden, what we're able to do in real time is do deep predictive analytics to identify what is the risk of that person defaulting on their loan. So at the point of contact, so when the business user has that person on the call, they can then have an line of business application that provides a risk score. It allows that risk to be then changed based on the information that's been provided, and then potentially change in the interest rate on that loan to then go and reflect the level of risk associated with that. But the key thing is the ability to do that directly while the person's on the call. So if the person was to leave the call, that person would be at risk and potentially going to another loan provider or another competitor. So really that are massive amounts of predictions that can be done directly inside of the database platform there. But what also with SQL Server 2017 is it's taking advantages of a number of changes inside of the GPU, so the graphical processing unit inside of the computers as well. So many of the advanced analytics algorithms are designed to be optimized for a GPU rather than a CPU, and SQL Server 2017 takes direct advantage of that. So one of the key things around the database platform is also around security as well. So with SQL Server 2017, there's a number of capabilities that are available inside of the product. One is around always encrypted. So what Always Encrypted does is means that we can then enable that inside of our .NET library, meaning that whenever I connect to SQL Server, any data that's transmitted across the wire is encrypted. If you were to go and get some sort of network sniffing tool today and you aren't using an encrypted connection, what you will see is that much of that data that's being passed between the application and the database environment can be sniffed out. So whether that's parameters being passed into a stored procedure or whether that's result sets that are coming directly back from the stored procedure. So by utilizing Always Encrypted, it ensures that any data in transit is protected there. We also have the ability to then protect sensitive data with dynamic data masking. So when we think about organisations today, data is more important from a privacy perspective than any time ever before. There's new privacy legislation being introduced around the world as we speak inside of the European Union. Australia's recently released new privacy legislation within the 12 months to really then make sure that people's data is protected and that there is a data breach that they then can't get the personally identifiable information from that. So what dynamic data masking does is allows us to then mask an individual column. So we can then protect those highly protected fields, whether that's a social security number or whether that's a credit card details in there. So that way all of that data is hashed. We also introduced the concept of what's called row-level security as well. Now, row-level security allows us to ensure that we protect an individual piece of data. Now, there's been a number of high-profile cases, both in the US as well as in Australia, of public servants accessing data that they shouldn't have accessed there. So what row-level security allows us to do is to protect their data at the lowest level inside of the database, no matter what application is used to connect. So whether you're using Microsoft Excel to connect to the database, whether you're using Microsoft Access, or whether you're using a line of business system to connect into that. Now the scenario might be I'm a nurse, so the nurse should be able to see any patient data that she's had association with, so any patients inside of her ward. However, if she was to somehow get access to the entire list of patients, row-level security would then protect that to ensure that she only has access to the data that she has touched. So there's a way to go and create a classify function and then go and protect that data that sits inside of the database environment. And finally, we've also got the file level protection as well to be able to protect our data at rest. So the data at rest is the data that's sitting directly on our disk inside of our MDF and our NDFs, but it also allows us to encrypt our database backups as well. So one of the key things around that is often database backups are moved off-site, whether that's off-site from our data center or whether they're off-site because we're moving them somewhere else there. If you were to go and open up a hex editor and then go and have a look at your SQL Server backup, what you'll find is that the data available in there is effectively plain text. So you can search for things like street or credit card details and find all of that information contained inside of the backup. By enabling TDE or transparent data encryption, it ensures that the data is protected at rest. So SQL 2017, we have Always Encrypted to protect the data in flight and transparent data encryption to protect the data at rest. Now, one of the key things we spoke about briefly before is the ability for the SQL Server to run on any platform of choice. Now, this is a game changer because I can then go and deploy my data platform on whatever environment I choose. Now, whether that's Windows or Linux, the behavior of the platform is identical there. So I have a consistent experience across whatever deployment mechanism. So when I deploy on Linux, I have three choices that I've got available to me. I have available Red Hat Enterprise Edition, I have Ubuntu and SUSE Linux on side of the Enterprise Edition as well. What I can also then do is I can deploy my environments, whether it's Windows or Linux, directly inside of a Docker container as well, which provides additional flexibility, especially in a continuous integration and a continuous deployment environment there, where I can then go and do a pull to go and get the latest container and deploy and test directly inside of that environment there. So certainly a new way and a different paradigm to think about how we go about deploying SQL Server. But remembering the key about that is it's a consistent experience no matter what part of the data platform I deploy and on what environment I then go and deploy SQL Server 2017. Now, when we started the session, we described that the data platform is now really starting to extend, and it's no longer what's directly inside of the box product, but it's also the cloud services inside of Microsoft Azure as well. So what we're going to do is walk through what some of those new data estate looks like directly inside of the Azure environment. So today what we have inside of the operational data set is we have our Azure SQL database, but we also have Azure Document DB as well, which allows us to then go and deploy NoSQL implementations directly inside of the cloud. From a data warehousing perspective, we have our Azure SQL Data Warehouse, which allows us to have MPP architecture or multi-parallel processing architecture delivered inside of the cloud in a pay-per-use model. So I only pay for what I need to then go and utilize inside of that environment. We also have the ability to then go and have our big data environment directly inside of Azure with Azure HD Insight. And also we have the Azure Data Lake as well. So when we think about the data lake is really the ability for us to have our data there cataloged and easily accessible to. Now, when I think about the data lake, the description I often use is describing then we might have a dam, we know how much water is in there, we know the quantity of the water that's there, we know where it physically is, but we're not quite sure of all of the consistency of that data. We may not put a straw directly into that dam and drink directly from that, but what we want to be able to do is be able to tap a data pipeline in there at some stage and extract value out of that. Now that would be a data pipeline where we would bring that and extract that and bring that into our line of business systems. So the same way that we purify water, we take it directly from the dam and then finally we put inside of the bottled water. When it's in the bottled water, I trust it, I know what's there, and I've then gone and done the analysis to know what the pH levels are, how much sodium is inside of that there. So I have a very clear consistency inside of that water. So really what a data lake is a mechanism that allows us to tap into at a time that suits us to extract value and bring that directly inside of our environments. We've got the ability to provide data insights with a number of different technologies. We've spoken about Power BI and how that allows us to democratize data and make it available to everybody. But we also have Azure Analysis Services now. So Azure is now a cloud service that we can deploy directly into in a PaaS-style environment. So, which means we don't need to worry about going and deploying SQL Server. We can then simply use that on a consumption basis as well. We have the Azure machine learning capability that allows us to provide deep, rich insights into our data, and stream analytics that allows us to extract value out of data in real time. So if we think about a manufacturing line where there's a lot of products that are being produced, I might want to extract some insight directly across that before the data is even hardened inside of my line of business systems there. So I might have some cameras or sensors that are running across that production line that are identifying whether there's any issues with a bottle, whether that's full to the right level, whether there's any foreign contaminants inside of that bottle there. So I can use Azure Stream Analytics to then gain insight of that data in real time while it's still in flight. One of the most exciting things that we have inside of the advanced analytics capability inside of Azure is Azure Cognitive Services. So some of the cognitive services that are really powerful is the ability for us to go and take speech to text recognition. So to be able to take somebody that's spoken, whether that's in a call center or in another scenario, and the ability to not only translate, but identify what locale and what language they're spoken in, but also the ability to then identify the sentiment as well, so whether it was a positive or negative experience. Some other things that we can do inside of the Azure Cognitive Services is around picture insight as well, so be able to go and take an image and recognize that. So whether that's used in cancer analysis to be able to then have a better and deeper analysis looking for potential risk, or whether that's being able to look through a crowd of people and identify an offender, or the scenario that we described at the start, where being able to then do number plate recognition and feed that back into a line of business system there. So one of the key things to understand with Azure is the security components around that. So that Microsoft Azure is the most certified cloud provider in the world today, and meets almost all of the regulatory requirements across the world there. Having recently also achieved a number of different levels of classification for defence, it means that the environment is very secure and data can be trusted in order to be able to leverage that capability inside of the Azure cloud. The other thing, as we said, is the flexibility that we then start to provide directly across the platform with all of our capabilities. So when we think about SQL Server 2017, the key thing is then that we can then go and power our data estate no matter where that sits, whether our data is on-prem, whether our data is in a platform as a service, or whether that's in an infrastructure as a service cloud provider there. And the ability for us to then seamlessly move data across all of those components inside of the environment. So in wrapping up, when we look at all of these components, SQL Server 2017 provides an intelligent, trusted, and flexible platform that can be utilized across any environment. So that brings us to where we wanted to finish today's session. What we're going to do is have a look and see if there's any questions. So if there's any questions that you have about the presentation today, feel free to pop those into the question pane, and I'm going to hand over to Michaela now.
Thanks, Peter. As everyone said, if you do have any questions, please feel free to type away now. Okay, I don't think we have any so far. If you do think of any, Peter's email address is on the screen, so feel free to get in touch with him directly after the webinar. Thank you, everyone, and thank you, Peter, and see you next time.